continuing circle work, dealing with conic sections and everything like that. So we talked about conic sections a tiny bit last time, and we're not really actually going to talk about them today. Today we're going to talk about center of a circle, radius of a circle, and the equation that is then formed from it. So it would be beneficial if I grab a copy of the notes, but go ahead and look at the notes that you have in front of you. That first circle there should be a little bit more manageable to work with compared to, I don't know, not so nice circles. Elena had a bottle of sass juice this morning? I'm sorry. Was it like expired sass juice too, and it's like extra sassy? You got kicked rocks? Are you using that as like the figure of speech, or are you talking like literally kick rocks? Literally, because I know there's the expression of like go kick rocks, and that essentially means like go away. You can't, look, you're like, what, 13, 14. You can't tell me that something is not an expression when you have grown up in a completely different time, in a completely different place.
Well, she can.
Okay, you can't with like accuracy. Like you saying that doesn't make it true.
Maybe it does. You don't know.
That's like when I say like you're slower than molasses in February, and you're like that's not like well, yeah, that's not a saying around here because who knows what molasses is. Well, then you all should understand how it's a saying.
Yes, actually.
All right, if
That's a saying. No, the saying is go eat some cake. What? Yeah.
Maybe now since Portal. All right, now, so wait a minute. Is this our diameter across at 3? Is this our diameter across at 4? Is it in between them is what we kind of need to figure out here. So we want to look at the curve of the line. Sometimes our circle is nicer and sometimes it is not so nice. Does this look nicer or not so nice?
Very nice.
Okay, so we're saying our center goes across our line of 3 then?
Yes.
Okay, so if we want to lightly draw that. And we can verify that, right? Because we know the diameter, if that is our diameter, will be equidistant from top and bottom. So 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5 down. Okay, this is a nicer circle. Must be why we're starting with this one. So I could draw 2 diameters. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I could actually just count my radius here.
No.
No?
No, because they didn't give you the points. Look at the points at the beginning.
Well, I have a question. Yes, you can, Liam, but it's also easier just to look at.
No.
So all because you say no doesn't mean it's true. Just like all because you say what I said was not a saying. Which what makes something a saying or not a saying?
Everything Liam said is true.
I mean, most everything, yeah, I'll agree with you. Omar? I don't know that we did anything on Friday. Oh, all we did on Friday was took the unit test. So you need to catch up on the unit test in math, but we are starting new content tomorrow. So no one really knows what to do right now. We're starting new content. What you need to do is follow what I'm doing, draw what I draw, and then ask questions as stuff doesn't make sense. So all we're looking at here is what is the center of the circle based off they gave us a circle, and we know the center is the point equidistant from all of the sides. And this circle is nice, right? We could go ahead and if we want to like somewhere say this is a nice circle. Oh, nice circle.
How do you know that like the line, the horizontal line was like splitting, or was it that even?
I seen it. No, I saw it, right? I looked at it. I said, okay, if I see the top of my circle, bottom of my circle, left side of my circle, right side of my circle, I know at the furthest out point of the curve is going to be where my diameter hits. So if I draw a horizontal line across here, I know that's not my diameter. It's just a chord, right? Just some random chord. Not squiggly. So we could actually just draw horizontal lines until we get the biggest line possible. The other thing we can just like look at is if I start drawing as many lines across the circle as I want, literally like infinitely many, the point of concurrency, which is where the point of intersection, right, of my longest lines. So I'm trying to start with like a really easy one, then we'll look at the more complicated ones. So in con, it's going to say like, what's the center? And the only way that we can figure that out is either visually say, oh, well, this is nice. This arcs at its furthest point here on a nice line. Or we'll look at the not so nice circles here in a second. So when the circle's nice, we can just draw a diameter horizontally and a diameter vertically. And we can find the center just visually. Right? So our center here is going to be negative 1, 3. With a radius of 5. So now take a moment to move down to the next one and see, well, okay, it obviously doesn't look quite so nice automatically because where the circle like arcs out is not lining up with our lines. Man, well, that's a pain in the butt. Take a moment to try to figure this out. You've got that ruler.
Can you just like also eye it and then check your work?
Yeah, what do you mean? Tell me more. What do you mean by like eye it?
Well, I mean, like there's most obviously a center there.
There is obviously a center because it's a circle. I agree.
But like you can dash it around there, put a point, and then get how far it is from the side.
Oh, okay.
What I did.
I mean, so you're saying, like, now would that be operating on the assumption that it's gonna be at one of the like intersecting crosshair sort of lines?
Well, you can,
What do we know about the center of a circle, Alina?
I was just gonna say you can count the number of.
That's exactly what I wanted you to say. The center of the circle is one. So I agree. The center of the circle is equidistant from the edges, right? So if we count what we think to be the longest span across the circle, well, guys, I can guarantee you that this span across the circle is not as long as this span across the circle. For this to be our diameter, and I should just use my ruler and draw a light line instead of make it so sloppy. If this is our diameter, it will be equidistant from the left and right sides. Right? So exactly what you guys are telling me to do. Okay, so count. So if I pick a point here, what? Are you laughing at me saying count?
Isn't that like the obvious thing to do though?
Yeah, you're right. But not to everyone necessarily. 1, 2, 3, 4, 5. A little extra. 1, 2, 3, 4, 5, and a little extra. 1, 2, 3, 4, 5, and a little extra. It looks like we're on to the right path. Yeah, since all of these are 5 and whatever this leftover segment is, these, just when I just look at it, obviously, geez. Now, I hope anyone in here who that wasn't obvious for you, like, it's not just obvious. It depends on our brain. Depends on if your brain is kind of an algebra-leaning brain or a geometric-leaning brain. So those of us with more geometric brains, which I don't necessarily know that mine is, you can kind of just like visualize where the center is and then double-check it. Those of us that don't necessarily have that skill could also, if we have a ruler or a measuring device like in the application, we could figure out, well, where is the widest, right? If I keep my 0 on the circle and kind of follow around, this is our widest point. But then our circle passes, so the center's nice. But out here, I'm not even sure exactly what that point is. It's 8 something.
Well, it gives you a point.
It gives me a point that I can use. So we use 7, 6. Oh, wait. So we never even talked about this up here. because we didn't need to, but when they give us the point, we can draw a triangle and figure out the radius this way using our distance formula or our Pythagorean theorem. Distance formula and Pythagorean theorem are the same thing, so you can use whichever one you want.
You don't even need to do that. You can just make it into a square, which is
Make this into a square?
so basically,
So hold on, let me finish my idea before you tell me a different idea, because apparently you guys don't like my ideas. So this, it's okay. You don't have to, like, I have never been the popular kid, so it's all right. So 1, 2, 3, 4, I get for this leg. 1, 2, 3, 4, I get for this leg. And what? Oh, yeah, thank you for asking that. So I drew out my radius out to the 0.76 that they had told me. Made my right triangle. And then I get legs of 4 and 4, so 4 squared plus 4 squared, 32. So the square root of the... So I think this will be radical 32. Which, if possible, to simplify, we will. And that, of course, can turn into 16 times 2, which would be 4 radical 2. We're going to be using simplified radical form these days because it's better than decimals. Now, we could have also used our distance formula. So to make sure that I give that some credit and write that out for you, if you go back and find your distance formula, that would be d equals the square root of, and I'm quickly going to end up off of the camera. I'm going to make this the simple distance formula, right? Delta y squared plus delta x squared. But to do those, we're just subtracting the points, right? So if this is 7, 6, and this is 3, 2. Well, my delta y, 6 minus 2. My delta x. Crap, that was my delta x. No, yeah, that was my delta y. If you want to see Mr. Hudson argue with himself. Four squared. Oh, hey, look, it's the same thing. Yeah, I definitely did not say this is the easiest route. I'm just giving it credit that this route will work. Because if the numbers suck, sometimes this is the better option. Remember, when the numbers get crappy, sometimes the option that right now doesn't feel like the easiest, sometimes it's just the easiest. Especially, guys, if we start to train our calculator. Like, if there's a program on our computer, like when you're older and there's no teacher saying you have to solve this way, when you've got programs to do this, sometimes it's just as easy to drop the points in. Right? If you can just drop the 2 points in and you've got a program running distance formula. So, moving on over, this one isn't very nice either. What? Sorry, I hear some whining. What? It's not nothing. Is it talking I need to be aware of? Why aren't we doing which one? The one at the bottom right?
Yeah. What's the question?
Exactly. It's a different question.
So what's the question?
Man, you need to drink less sass.
You didn't give us the question, so how are you going to do it? This is misleading.
Do I have your permission to move on? So I can give you that question that you oh so desire. So we can loop back and also solve these two problems. But guys, it's the same thing where you want to visualize what horizontal would be equidistant from the top and bottom, and what vertical would be equidistant from the left and right. And that then is how we find our center. And again, you can use Pythagorean theorem or distance formula. They give us -5, -9. So we could use this point. Either way, it's like a 1/2 triangle that they form to then make the radius. This problem, this trapdoor example is not asking you what's the center, and it's not asking you what's the radius, because, well, that just feels way too easy. We'll come back to this after we look at the back so you know what the question is. Look at this question. Well, more so command. I guess it's not really a question. Great. That's the question that goes with the trapdoor on the front. Sorry that I can only print in such a amount of space on the paper as limited by the computer, and you disagree with that. I know how much space I want for things. So this is your golden ticket. It's also why I don't put it on the front of the notes, because it's almost like too easy when it's like right in your face. The trapdoor that catches everyone is when we write the equation of the circle, it feels like what we're putting in here is the opposite of the x value of our center. And it feels like what we're putting in here is the opposite of our k value, because it is x minus whatever the number is and y minus whatever the number is. So the first one I actually want to go look at is the third one on the paper. Guys, I put these on here and then I actually process through the notes that I've already printed. I'm like, oh yeah, I should do this one first. When your numbers in your equation are both positive, the trapdoor is people are like, oh, the center's at 7, 8. The center is the opposite of this number shown. So it's -7, opposite of this number shown, -8. And the square root of the constant over here. So in this case, our radius would be, what's a square root of 4/9? Yep, 2/3. So be careful to avoid the trapdoors. Find the center and the radius for all other 3 of those. Excuse me. We're just going to play a little round robin here and go around the room. So, Aaron, what is the center of our top one here? Yeah, and Margaret, what's our radius? Oh, my bad. Good catch. Yeah, our radius is 10, right? Because 100, we got to take the square root of 100. So our radius is 10. Amar, this one gets a little bit trickier. Let's start with the x value. What's the x value of our center here? Yeah, so we come over here and we essentially take the opposite of what it looks like. And then what? Can you tell me what you think the y value, like what happened that this is just y squared?
They basically,
Think about what could have happened that we just ended up with.
they already did y minus k already, that's fine.
And what was the k? You can throw it to Alina if you want. She was like in front of her. She was kind of motioning that she knows what. You can answer the radius here in a second. This would be anyone. 0. When there's nothing with the variable over here, this, and you want to make this note, would have been y minus 0 squared, because 0 squared disappears. And it could have been y plus 0, because who cares? Y isn't positive or negative. Alina, the radius? Which is? Wait, the square root of 1 is... The square root of 1 is 1.4? You're thinking the square root of 2. What number times itself gets 1? It's just 1. Yeah, be careful. I think you were thinking of the square root of 2. Square root of 1 is 1. 1 is the only quote-unquote perfect square that is its own square root and is its own square. Because negative 1, when squared, becomes positive 1, actually. Right? Down here, let's go Avi. What's our center for the final one? Yeah, 0.5 and 3.5, both positive. Katie Ann, just because we haven't really talked, what's the square root of 6? Yeah, square root of 16? 4. And moving on now. Wait, Aaron? I like the question, but can a distance actually be negative? No. So this is when we ignore some of the mathematical solutions because they're not practical. So even though mathematically a square root has 2 answers, this is where in this branch we only look at the positive answer. So Aaron, you're absolutely right. There are branches of math, and actually like even doing this where we would say positive or negative 1 and then we like throw out the negative 1. But mathematically, negative 1 would work, quote unquote. And depending on, like, if we're in a real deep branch of physics or talking about dark matter or stuff, we look at the negatives and see, like, what might happen. Like, that might be the upside down, right? If you watch Stranger Things, anyone? No? Okay. Yes. Okay, I don't even know when we leave. I still gotta loop in Elle and Kaylin, too. I haven't picked on them yet. I only have 9 minutes left. So, yeah, I know time flies when you're having fun. It's not meant to be funny. It's just an old expression. Unless Katie Ann tells me that it's not an expression, and then maybe it's not. Time flies when you're having fun. When we go to write the equation, sorry, I almost said expression, of this, we're going to set it up in standard form. So this is what we call standard form of a circle. So it's not a y equals equation, right? It's not like in function form. So we're going to have an x equals, an x plus or minus something in a parentheses that is going to get squared. Same thing with our y, and our constant out here will be our constant out here. We could then push it into y equals form, but it's real messy to do that. So we'll look at that later, not today. Kayla? Can you give me a guess for why we use h for the x value? H actually does this. Horizontal. Can you make a guess of why we use k for the vertical? I mean, we can go ahead and guess horizontal, vertical, right? But why would we use k? V gets used for other things too. Right? We don't really use K. I know, we're about to get there. We don't really use K for much, except for sometimes people use K in a constant form, right? They use K instead of like C or K instead of B, like in y equals mx plus b. But really, the agreement that was made, like whoever agreed, some council of mathematicians, I'm not joking, said H and K. We're going to go with H and K. So they are just like the placeholders. H horizontal makes sense. K doesn't make as much sense. It's our vertical.
What doesn't make sense?
You're right. So be careful when we go to fill in our values here. You might feel like it'll be negative 2.4, but it's not. It's positive. And this will also be positive. And then what would we put over here? Because over here goes the r squared. 45. Go ahead and try the next one on your own, and then go try that picture on your own. The point of these points. Okay, the purpose of these points. You guys are a bunch of wet blankets. The purpose of these points is so that you can set up a triangle. So knowing that this does not drop nicely to a value that we know, they do give us that this is locked in on the graph. It does actually have that point on the edge of the circle. So from there, we can set up a radius that we know is true. Mari, you got to catch up with us, right? Because you were gone for a second, so make sure you get down this equation that I got written in blue and pink. And then we're working on the next ones on our own. Then you can flip back to the front and look at that trapdoor one as well. My favorite color is students that do work. No, actually, so it used to be like blue or green, but now I really honestly think it's purple. But it depends what we're talking about. Yeah, because if we're talking about what color do I want to paint my walls in my house, it's not purple. But if we talk about like what color do I want to write with when I write in my notebook, I like purple. Like, what do you mean in general? That's such a deep question. Purple.
No, that would be gray. Yeah.
What do you guys have against me saying purple? Why can't I say purple? Kaylin, save me from this conversation. Our equation will be x quantity squared. Be careful. So as we start to say this out loud, sorry, I kind of set like a trapdoor for you. We would say x plus 2.3 quantity to represent everything we just said squared. And, yeah, I just really don't like saying open parentheses, close parentheses. I feel like a robot when I speak like that. So then, oh, I don't even really need this parentheses because if my y value is 0, so for anyone that wants to write it down, it's y plus or minus, doesn't matter what we would put in there, plus or minus 0 squared. That's going to be just y squared equal to 36 over 49. I highly doubt it. I mean, this one's divisible by 3, but this one is not. So I kind of doubt it. L, coming to you for our last one on the back here. What is the radius in this situation? Square root of 18, which actually we can write in a little bit nicer simplified form. Ah, good point. So since we want to write the equation, leave it as radical 18. So then our equation becomes?
X plus 5 squared plus, well, in the parentheses thing, plus, in parentheses, y plus 5 squared, and equals 18.
Oh, because that just essentially gets rid of the square root. Awesome. Why the one on the front door is a trap door, Alina? Well, I mean, I don't know. You're the one saying like what? You tell me why I think this is a trap. What is the equation? Well, I guess if we discuss the equation, we can maybe figure out why this is a trap door. Where are we at? Where's our circle centered?
Trapdoor is the unit.
Where's our circle centered?
-2,
-2, right? So as I go to start writing this equation,
Did you say the center?
yeah, the center.
Where is the circle centered? The center.
Oh, you mean somebody said it's centered at the center. Oh, well, yeah, that's kind of funny. Alina, what did you mean the trapdoor is the units? Because, I don't know, our radius is 3, so I'm just going to...
No, it's 3 times the unit.
Yeah, 3 times the 1 copy.
How big is our radius actually here? 0.75, which honestly is not that nice to work with. 3/4? Yeah, 3/4 is honestly a little bit nicer, in my opinion at least. But that's up to you guys. So this is either 0.75 or 3/4, right? But it is not a radius of 3. Guys, anytime you see that your units are not 1-to-1, you should indicate that. You should put a little note for yourself, because it's real easy to write this down and then go, oh, 1, 2, 3, 9. It's not 9 because this is not 3. It could be 9/16. Or if you do it as a decimal, 0.75 times 0.75 is, I don't know, what it, it's not nice. It's I think it goes 4. I think it goes 4 decimal places.
I think it's 0.512 something.
That sounds right. This is going to be over half. It's going to be a half and another, hey, it's a half and another 16th, right? 9/16. So what is a 16th? It's half of an 8th, right? If an 8th is 0.125, 0.0625? Yeah, so if a 16th is 0.0625, then we'd have 0.5625. Yeah, I think it's 0.5625. I think. How many bees?
Yeah, honeybees would fit in half a cup.
Not very many. Honeybees are pretty big. 7?
No, honeybees. You know the tiny ones?
Oh, not the furry ones, but the...
Those are carpenters.
Well, still, a half cup is only 4 liquid ounces. 100?
100.
No way.
Yes.
I mean, I guess when they ball up. I always feel like bees are big because they're scary. Well, bees scare me, so I think I feel like they're bigger.
But I took a beekeeping class, and one of the things was take a half cup of bees, put it in a jar, put sugar in the jar.
Well, I guess if we think about the math, also I'm entertaining this conversation because I have to go to a meeting once you guys leave. If we think about the math, isn't it 1 bee per honeycomb? The hexagons they make? Elle, you can't get me interested and then leave the conversation. Don't they make the size of their nest to be the size of them? They can fit in the... So if we know how big the nest is, I could do the math. I'm bad at guessing. But give me the math and I'll do the math.
Oh, you heard of paper wasps?
Paper wasps?
Paper!
I don't know if I want to.
They're actually not that bad.
Anything with wasp in the name.
I have them at my old house, above my door.
They sting and bite.
They're cool. You
Well, I know that they're cool and bees are important, but they sting and bite. Blue group, if you're still watching, I appreciate it. You should send me an email or a comment about how many bees you would have thought would have fit in a half cup. Sweet. Hopefully you guys understand all the circle work, and I'll see you next week. And please email me if you have any questions. Otherwise, we'll keep moving forward as soon as you guys get back here on Monday. So have a great week.